Hello, let us try to solve this problem here. Now I have the differential equation of fourth order differential equation, and it is um, now which is of the Cauchy's form. Let us convert that into a regular normal differential equation and then try to solve this. Okay, now as we have seen in the earlier part of my sessions, wherein I have been trying to solve the problems, so henceforth let us again try to solve these kind of problems here. Okay, then let us write this in it can be written like this. So that is x power 4, this is d power 4, and so y will be common for all, so I'll put that. So this is equal to 6x cube, and this is d cube, and plus 9x square, and this is d square, plus I'll have 3x d, okay, plus 1 into y is equal to 0. So this is the above given equation can be written in this form, and let us put that as log of x, which is equal to z. Okay, so or we can write x is equal to e to the power of z. Okay, then okay, so we get x d as d1. Let us substitute that, and x square d square can be written as d1 multiplied with d1 minus 1. Okay, and x square x cube d cube can be written as, this would be d1 into d1 minus 1, okay, and d1 minus 2, right? Okay, now again let me put what is x power 4. Okay, so x power 4 d power 4, so that would be equal to, this is d1 into d1 minus 1, okay, multiplied by d1 minus 2, okay, and d1 minus 3, right? Now where we have considered d1 as d by dz. Okay, let me further continue problem. Okay, let us see that. Let us substitute all those which I have mentioned. So that is, first one would be d1 and d1 minus 1, again d1 minus 2, okay, and d1 minus 3, plus we have 6 times that of d1, okay, d1 minus 1, and this is d1 minus 2, okay, and further continuation 9 times that of d1 and d1 minus 1, close the brackets. No, we have further value, right? So let us continue that. So this would be plus 3 times d1, 3 times d1, and the last term 1 into y is equal to 0. Okay, now when we try to simplify further, after simplifying everything, we get into this the normal differential equation, which is this, plus 2d1 square plus 1, okay, multiplied by y is equal to 0. Okay, so we got the the differential equation, which is of fourth order differential equation, and it is homogeneous equation. Okay, now we know how to solve this. Auxiliary equation would be, that is m power 4 plus 2m square plus 1 is equal to 0. So you will be having 4 roots here. So the roots we get as m as plus or minus I and plus or minus I. So root are repeated. So let us write the complementary function corresponding to that. So that would be yc is equal to, so this will be c1 plus c2. Now this is in terms of z, so z, okay, and this is cos z, right, plus, so you'll have c3 and you'll have c4, right, 4 roots, so 4 constants, okay, z and sine z, right. So let us write in terms of x here. So let us write the final one of the complementary function. Yc would be, that is c1 plus c2, okay, so that is multiplied by z is log x, okay, so multiplied again this with cos of log x, okay, this is done, and we have another term which is c3 plus c4, this is log x again, okay, because z is log x, so I'm writing that, and sine of log x. So this is done. So we have found that is complementary function. Let us find the particular integer. This yp is equal to, since we on the right hand side it is not equal to 0, it is equal to 0, so this will be we will not have particular integral, so the solution y will be c1 plus c2, this is log x, okay, and cos of log x, right, and plus c3 plus c4 and log x, okay, and sine of log x, right. Let us try to solve another problem here, okay. Okay, here this is of another type of problem. Let us try to solve here. So how can we write that? So again, same process. Now here you have 2x plus 3, okay, and it is multiplied by d square, okay, minus 2 times 2x plus 3, right, into d minus 12 into y, okay, so that is equal to 6x. Now let us put, that is 2x plus 3, okay, now this is of the form of Legendre's equation. So again let us put log of 2x plus 3 is z, okay, or we can write 2x plus 3 as e to the power of z, okay. Now we have this as 2x plus 3 is equal 2 times d1. Okay, this is for d. Okay, first derivative. Now for the second derivative, that is, you have as 2x plus 3 whole square. Okay, this is d square, which is equal to 2 square, and it should be d1 and d1 minus 1. Okay, so where d1 is equal to d by dz, right? Let us try to simplify further. So let us substitute all those which I have mentioned here. So that is 4 times d1, okay, into d1 minus 1, okay, minus 2 into 2, okay, so d1, fine, minus 12 into y, so which is equal to, so in 6 into, now we had, if you look at that on the right hand side, you had x, right? So x will be half of that is e to the power of z minus 3. So that's what, let us substitute those things. So this will be half of e to the power of z minus 3. Okay, so after simplifying that, so I get the final as 4d1 square, right, minus 8d1 minus 12, and it is multiplied by y, which is equal to, if I try to simplify this everything, so I get 3e to the power of z minus 9. Okay, now since we got this as a differential equation, which is of second order differential equation, and it is non-homogeneous, let us first find what is auxiliary equation here. So let me write that auxiliary equation here. So this would be 4 times that of, if I remove 4, if I remove that, so I'll get d1 square. Okay, or in this form I can write, so that would be, that is m square minus 2m minus 3 is equal to 0, right? So the roots which we get as m as 3 and minus 1, so your yc would be, okay, c1 e to the power of minus z and c2 e to the power of 3z. Okay, so that's what we get it. Now in terms of x, you can write this as this is c1, okay, and this would be 2x plus 3 to the power of minus 1, and this would be c2 2x plus 3 to the power of 3, right? So this will be your yc. Now let us find what is yp. So yp will be, okay, let me do that. So that is 3 times e to the power of z divided by this is 4 d1 square, right, minus 8 d1 minus 12, right. I'll be trying to solve both the particular integral here. So minus, this is 9 divided by this is 4 d1 square minus 8 d1 minus 12. Okay, now let us put the values. So here, if I consider for this, if I consider d1 as 1, okay, and I will consider d1 as 0. So for this, okay, let us substitute that. So I get, after simplifying, I get this as 3 e to the power of z divided by this will be somewhere minus 16, and this is minus 9. So I have substituted 0, so I'll get minus 12 in the denominator. Now further, if I try to simplify this and I'll replace e to the power of z also, so I'll get yp will be minus 3 by 16. Now this is 2x plus 3, right, plus, if I simplify this, so I get plus 3 by 4, right. And the final solution for the differential equation, y is equal to yc plus yp. Okay, so for more problems, we have already done some of the problems here. You can subscribe, as well as if you have any queries, you can post the queries. I'll be ready to help you. Okay, and there are some video links also, which is displayed right on the screen.